Okay, so good afternoon. Ang pag-usapin natin ngayon ay ang concept ng machine learning. So in the next 4 meetings, we'll go briefly dun sa concept ng machine learning starting from yung tawag dito. Well, syempre i-motivate muna natin kung bakit natin kailangan matutunan ito, and then we're going back to yung concept ng gradient descent, because this is gradient descent is really a fundamental concept pagdating sa machine learning. And the idea is just to minimize yung errors between yung information na pinifeed nyo sa tawag dito sa computer at yung knowledge na generate ng computer. Okay, then titignan natin yung mga codes na relevant sa machine learning, and towards the end or after this, so remaining 4 meetings na lang tayo. So on the 4th meeting, makikita nyo yung ang ipapakita ko sa inyo ay kung paano generate ng model, ng machine learning model to classify images. Okay? And yun din yung magiging ano ninyo. Yun din yung magiging machine problem ninyo. So, let's see. Bakit natin kailangan matuto ng machine learning? Okay? So, of course, ito yung ano ngayon, diba? Parang hype ngayon, nadidinig nyo yan, nakikita nyo yan sa social media, didinig nyo sa sa kung saan-saan, sa papanood nyo siguro sa TV. At maraming mga companies ngayon and institutions ang nag-i-implement na ng machine learning or artificial intelligence. Itong mga companies na nakikita nyo rito, okay, like Google for example. Google by itself ay nag-incorporate na ng artificial intelligence sa kanilang mga products. Sa search, of course, sa search engine nila, nag-incorporate na sila ng machine learning or AI. Sa Google Maps, okay, sa Pixel, Google Pixel, sa Photos, YouTube Assistant, Gmail, sa pag-determine ng ads, sa cloud, sa spam, and so on and so forth. And Google is also one of the companies na medyo advanced na pagdating sa research on artificial intelligence. Okay. UP, for example, sa Diliman, meron na silang MS at PhD on artificial intelligence. Okay, and actually medyo behind na ang Pilipinas pagdating sa artificial intelligence at machine learning, kasi this has been tawag dito, this has been going on, or sort of sabihin natin the trend started since early 2000. Okay, now yung unang machine learning actually started way tawag dito even a longer time than yung 2000. So for example, in 1997, yung IBM nag-develop sila ng program, tawag nila is Deep Blue, okay, na kung saan pinaglaban nila yung reigning na world champion noon na si Garry Kasparov against dun sa Deep Blue na model nung tawag dito, nung IBM. Okay, at hindi lang to isang laban. Okay, I think if I remember correctly, nag-compete sila several times, and tawag dito, eventually natutunan nung computer yung moves ni Kasparov. Okay? Quite recently, in 2017, yung Google ay nag-develop din ng model on playing chess. AlphaZero yung tawag nila. Tapos ito yung ginamit nilang mga methods, DNN at saka General Reinforcement Learning algorithm. Okay, yun. So, pinaglaban nila ito sa tawag dito. I don't remember kung kanino nila nilaban itong model nila, pero in that competition, AlphaZero, the model, won 28 times and got 72 draws. Pero hindi natalo. Okay? So every time na naglalaban siya, natututo siya about yung moves ng competition niya. Okay, so this just demonstrates yung power ng machine learning at saka ng artificial intelligence. Of course, alam niyo ng ChatGPT, di ba? Medyo ubiquitous na ang ChatGPT pagdating sa maraming bagay at maraming aspects. Okay? Kung hindi niyo pa na-try, you can ito yung niya, website. Try nyo, all you have to do is just log in or sign up. Walang fees ito. Wala kayong babayaran dyan. You can just try na gamitin yung OpenAI. So ito yung ano ba to? Okay, sige, panoorin natin itong video na to. Okay, wait. Sandali. Hindi ko alam kung na-share ko yung audio. Share sound.
It's also breaking records. ChatGPT is one of the most trending topics right now. It's been less than a week since its release, and people's minds are being blown with what it can do. It's also breaking records with over 1 million users signed up in just 5 days, faster than Netflix, Twitter, Facebook, even Instagram. No longer will you be Googling the answers to problems. ChatGPT gives breakdowns of them in fine detail, with explanations exactly how it works. This will make people question just how relevant Google will be in the coming future. Do you want to know the limitations of TypeScript? ChatGPT has you covered. But what exactly is ChatGPT? What makes it so powerful? These are things I wanted to find out. It's built by the same people that are behind OpenAI, which are now shaping some really interesting technologies. They've been building powerful engines like Codex, which is the engine behind GitHub Copilot, something that many of us are already using in our day-to-day coding on VS Code. And if you're looking closely, you might see the beginnings of ChatGPT, where people put in prompts and they get outputs from an AI-generated system. Another example was DALL-E 2, which was an image generator based on prompts you enter. Here you get different types of visualizations of a spaceman on a horse, and lots of other examples even extending out classical artwork. ChatGPT is therefore a way of prompting an AI to solve or answer a question or a prompt in a human-like manner, very different from anything else we've seen before. And this can sound scary, very scary, especially to organizations like Stack Overflow, which pride themselves on solving problems with human-related answers. They've actually gone as far as banning ChatGPT out from their systems. This is because they want to build a level of trust on there. And if people simply copy-paste answers from GPT without any references, that might break that level of trust. This is all quite interesting, but let me have a look at ChatGPT under the hood by actually using it and seeing just how useful it will become as part of our day-to-day lives in development as well as any industry. In case you didn't know, ChatGPT is entirely free. If you want to try it out yourself, simply go to OpenAI, log in with a brand new account, and then select the ChatGPT interface. I'm quite fond of the design. It's nice and simple, giving you the examples as well as some capabilities and limitations of ChatGPT. Some of these capabilities are quite powerful, things like remembering what a user said in a conversation and providing follow-up corrections as well. The first thing I wanted to do is to see if it could tell me what Python or TypeScript is. And it gave me a pretty sound answer, saying that TypeScript is a programming language that's a superset of JavaScript. Since I haven't actually used TypeScript before, I decided to ask it if it could give me a hello world function. Not only did it write the function in such a manner that I could literally copy paste it out, but it also explained the function to me. And this is really just the beginning. And here is where things get interesting. I've been working on a small application and I was getting an error that I couldn't figure out. I decided to copy paste this error into ChatGPT to see what it would say. Here's some JavaScript in VS Code for a upload for a video app I'm working. This code is failing when I try to run it in Node.js. I copy-pasted this straight into ChatGPT asking if it could fix the following code for me. What I received back was my code fixed. And not only that, ChatGPT went through and gave me the code to copy-paste and even explain to me exactly what was wrong, why it was wrong, and how it was fixed. In this example, I had written my return function incorrectly, basically making a bit of a typo. And here, it's gone through and fixed that return, making sure that it's spelled correctly. It's also being a bit cheeky here, adding in a comment that it fixed the typo right here on the line where it says return. If I didn't know any better, this could have come from a real human. Even, for example, a mentor or a supervisor that could be checking and reviewing your code. And this makes me question exactly what things might look like in the future of development, because this could really be like a personal assistant of a sort. But ChatGPT has a lot of relevance, even outside of programming, since it's practical to pretty much anything. Here, I wanted to create a list of food I can eat that don't include carbs because I'm trying to lose a little bit of weight. It gave me 3 dishes that I can have: grilled chicken, as well as shrimp, as well as some omelets. Taking this one step further, I asked if it could create a shopping list for me based on those meals. And yes, it did that very easily. Not only that, it indented them and made them nice and readable. I think that ChatGPT is here to stay. I think it'll be revolutionary. It'll become part of our day-to-day lives, similar to how Google has. And not only that, it's going to revolutionize so many industries once they take full advantage of it. That's just my opinion though. What do you guys think? Let me know in the comments below. And if you haven't already, make sure you guys hit like on this video.
Okay. So, yun yung description ng ChatGPT.
ChatGPT is one of
Here's another example, okay, na nakita ko lang sa internet. Okay, for example, dito, ang tanong ng user is how much is 2 plus 5? Ang sagot ng ChatGPT is 2 plus 5 is equal to 7. And then sinabi ng user na my wife says it's 8. Tapos sabi ng ChatGPT, 2 plus 5 is actually equal to 7, not 8. It could be possible that your wife made a mistake or misunderstood the problem. So yan, ang sagot naman ng user ulit, my wife is always right. And tignan niyo kung paano sinagot ng ChatGPT. I apologize. I must have made an error. My training data only goes up to 2021, and I may not have the most current information. If your wife says it's 8, then it must be 8. Okay, so dito lang sa small clip nito, okay, makikita niyo na nakakatawa siya, diba? Pero nakikita nyo rin kung paano natututo yung ChatGPT. Kasi any information na pinoprovide nyo sa kanya, tawag dito, will ay tinitake in niya as part of its learning process. Okay, so in essence, pwede nyo actually turuan ng mali yung ChatGPT. And you can also perhaps take a glimpse of what the future might look like. Diba? Kasi marami nagsasabi ng ML or AI could lead to people losing jobs or pwedeng i-overcome ng artificial intelligence yung buong mundo at i-erase yung, di ba, yun yung parang extreme na prediction. But you can see from this small clip na ito or small anecdote na ito na we can actually control kung paano tawag dito, kung paano natin gustong matuto yung artificial intelligence. Okay? So check this out. Ito yung website niya kung interesado kayo and maybe makatulong sa inyo in one way or the other. Okay, now even though matagal na tong artificial intelligence, okay, bakit ngayon lang dumating yung or bakit ngayon lang nag-boom yung machine learning or artificial intelligence? In fact, kung titignan niyo yung algorithm for artificial intelligence and machine learning, yung article, yung first article that published machine learning artificial intelligence ay 1950s pa. Okay? So, bakit ngayon lang nag-boom yung AI tsaka ML? Well, the reason is yung processing requirements, okay, ay ngayon lang dumating. Okay? So, early in the 2000, medyo bumibilis na yung mga computers, and that's because of yung mga chips na dine-develop nila, parami yung mga transistors na in-incorporate nila doon. Okay, at palit na ng palit yung mga transistors din. Nowadays, you can have very, very small transistor and you can incorporate billions of transistors in one small chip. Okay. And even that is not enough for high processing. Kailangan mo pa rin ng mga ganitong supercomputer. Okay, so I'm just gonna send, hindi ko na i-play ito. I-send ko na lang yung slides sa inyo as PowerPoint. Kayo nang bahala mag-play dyan. Okay, but yung point is kung bakit ngayon lang to is yung processing, yung mga computers na kailangan mag-process ng machine learning tsaka AI ay ngayon lang. Ngayon lang nagdadatingan. Okay, so paano ba natututo yung mga machines? Okay, so you can play this small clip. Okay, para ipakita lang. And in the same time, magde-describe lang ako. So machines learn just parang ganito, the same way as humans learn. Diba? So they learn by from their mistakes essentially. Okay? So dito nakikita natin na yung baby ay nagtry na tumayo, di ba? So makikita natin yung iterations na ginagawa niya to just try to stand in this case. So makikita niyo na tawag dito well, kung paano siya nagtatry na tumayo. Well, ang difference ng AI sa mga humans, okay, is that nga sa ngayon yung mga AI models ay parang definite yung parang sabihin natin brain cells or neurons, okay, na dinidefine na binibigay para dun sa model. Pero pagdating sa humans, alam natin na ang neurons ay tawag dito na de-develop habang tumatanda, habang nag-grow ang isang human. So for example, dito nung infant pa lang siya, wala pa siyang, hindi pa well-developed yung muscles niya. So yung neurons associated with the muscles used for standing ay hindi pa din available. And as this toddler grows, yung muscles niya na-develop, nag-create din siya ng mga bagong neurons. Okay, and that's not something that machine learning or AI is doing right now. Okay, so hindi pa yung programmer pa rin yung mag-create ng mga bagong neurons, okay, para dun sa model. So makikita natin yung complexity din ng learning pagdating sa humans at medyo malayo pa currently yung artificial intelligence sa ganong klaseng stage. Okay? So, ito naman is the same, tawag dito. Ito naman ay machine na nag-incorporate ng machine learning model para maturuan siya na maglakad. Okay, so of course dito, hindi na natin kailangan ng hindi siya nagbe-build ng neurons niya, di ba? So yung neurons niya ay set na, yung number of neurons ay set na. Okay, and nag-a-adjust na lang yung neurons in such a way na tinuturuan niya yung tinuturuan niya yung robot na tumayo. Okay, so of course, since a computer tawag dito aided itong robot na to, mas mabilis siyang matuto kumpara sa infant. Okay, and of course, kumpara sa humans, hindi naman ganun ka-complex yung system para tulungan tumayo yung robot. Okay? So, ganyan yung nangyari. So, in about an hour, medyo naturuan na siyang maglakad. Okay, so, makita niyo na medyo straight na yung paglalakad. So, ito hindi na to sped up. Ito na yung normal time ng walking. Okay. So machine learning can be tawag dito classified based on whether bibigyan mo siya ng information or tawag dito, kukunin niya yung information from ang tawag dito, from feedback. Okay? So basically, sa supervised learning, at dito makikita niyo yung difference, ano? Sa supervised learning, yung input data ay labeled. Okay? At sa unsupervised learning, yung input data is unlabeled. Ano ibig sabihin nun? So halimbawa, may gusto kayong i-classify. Gusto yung turuan yung machine kung ano yung bola, tsaka kung ano yung cup, for example. So ang gagawin mo is gagawa ka ng folder, at dun sa folder na yon, ipapasok mo lahat ng images ng bola. And then another folder, kung saan ipapasok mo yung images ng cup. So in that sense, nililabel mo lahat ng images na mayroong bola at inilabel mo lahat ng images na mayroong cup. So yung input data is labeled. Pag unsupervised learning, hindi mo ililabel yung data. For example, if you want to predict yung trajectory ng storm, for example, bibigyan mo lang siya ng set ng data over which siya yung mag-generate siya yung mag-figure out kung ano yung pattern mula dun sa data na yun. Okay, so yun yung unsupervised learning kasi pati ikaw as a user na nagbibigay ng data sa computer, hindi mo rin alam kung ano yung pattern. So hindi mo alam kung anong klaseng labeling ibibigay. So unlabeled yung data. Yun yung difference ng dalawang types ng learning models sa machine learning. Under supervised learning, meron tayong tinatawag classification at saka regression. Okay, this regression thing is the same as yung regression na inaral natin sa klase, and ito yung actually unang example na ipapakita ko sa inyo ng machine learning today. Okay, and then yung classification, ito na yung example din na sinabi ko sa inyo na, for example, ball versus a cup. Okay. Dito naman sa clustering, okay, ito isang method para tawag dito, para matuto yung computer. So ang ginagawa niya is kina-cluster niya yung data. Okay. Like in this figure. So kina-cluster niya yung mga data na similar, and then from there i-figure out niya kung ano yung pattern na makukuha niya. Okay? Based on kung ano yung parameters ng data. So yun, nakikita niyo yung mga tawag dito, mga iba't ibang methods dito. Ito yung mga models under this type of learning model. Okay? Okay, sandali. Just give me 2 minutes. Hello. No, nag-pause ako sa for a bit. So, kaya kala niyo siguro baka. Anyway, saan na tayo? Okay, so yun yung mga iba't ibang models. Iba't ibang techniques na pwede nyo gamitin sa dalawang types ng learning under machine. Okay? So, ngayon, ang titignan natin ay yung regression. So, ano bang difference pagdating sa humans at saka sa machines? Okay? Kung naalala niyo, nung ginagawa niyo yung regression, so ang ginagawa, diba, ang ginawa natin is gumawa tayo ng isang equation. Okay? Yung equation na yun is in terms of the error, kung saan kinocompute natin yung difference between yung actual data at saka yung model ng linear regression model sa natin. So, ang ginawa natin is kinocompute natin yung difference ng errors o yung errors between each data points, tapos minimize natin. So, ganun ang ginagawa natin. From that equation, makaka-develop tayo ng, or from that technique, makaka-develop tayo ng linear na equation na mag-fit dun sa lahat ng indicators. That's necessarily na, it isn't necessary na lumamalaman yung indicators na yun sa line, pero at least yung differences between yung best fit line at saka yung different points na yun ay tawag dito, ay maliit lang yun. Now, sa machines, hindi niya alam kung ano yung actually yung magiging equation. In fact, hindi niya ibibigay sa inyo. Or, well, ibibigay niya sa inyo yung slope tsaka yung line. Pero hindi niya naintindihan kung ano yung kung ano yung actually ibig sabihin ng equation na yun. So, ang gagawin niya is mag-guess siya. So, gagawa siya ng initial guess. Kung nalala niyo yung gradient descent ng MP ninyo, gagawa siya ng initial na guess, tapos mula sa initial guess na yun, titignan niya kung ano yung error. Tapos, base dun sa error na yun, i-correct niya yung guess niya. Okay, and titignan niya yung next guess kung gaano kalaki yung error. And then, base dun sa second na error, i-correct niya yung third guess, and so on and so forth. Hanggang sa maging pinakamaliit. Okay, so ang ipapakita ko sa inyo yung code is this. So, first of all, mag-graph muna ako ng tawag dito ng some function, okay, on the x at the y axis. By the way, yung nasa left hand, yung dito sa left ay MATLAB code at yung use Python code. Okay, so dito sa code na ito, ang pinapakita ko ngayon is yung x-axis, and dito naman yung y-axis. Dito sa MATLAB, gumawa lang ako ng function na add random fluctuations na kung saan naglagay ako ng kinol ko yung x, naglagay ako ng slope at saka ng tawag dito ng y-intercept. And then ito, yung degree ng fluctuation. So mamaya titignan mo sa MATLAB. Okay, so ito actually yung ating equation of the line mx plus b. And then yung fluctuation size, okay, which is in this example is 0. No? So dito siya papasok. Fluctuation size ito. So magdedepende yan kung gaano kalaki yung fluctuation. So yun yung mag-generate ng data. Okay, so basically ang ginagawa lang itong code is mag-generate siya random. Tapos i-plot niya. Okay, so now, kung naalala nyo sa MATLAB, ang ginagamit na function to determine the best inputs for it. Linear regression, ang 1 lang yan. Sa Python, okay, ang gagawin ng function stats.regress. And tawag dito, ito ay automatic linear regression kasi yan yung okay, so So basically, ang ginagawa ng coding test, i-determine niya yung best fit function. Kaya mag-generate siya ng polynomials, ng coefficients, coefficients ng slope at saka ng so ganun yung slope, y-intercept. Ito naman, yung P, mag-generate siya ng dalawang, since linear regression lang, dalawang parameters, yung isa yung slope. Okay. Then, tas, tapos i-fit natin yan dun sa random fluctuations na natin. Now, sa machine learning, ito yung code. Okay? Sa ngayon, it looks complicated, but it's actually very simple. It's complicated. It looks complicated kasi hindi nyo pa alam kung anong nangyayari. Right? Basically, itong SGDM, ito yung gradient descent. So, stochastic gradient descent by, nakalimutan ko na yung M. Pero anyway, yung GD dito is gradient descent. And dito rin, gradient descent. So, ito yung optimizer na tinatawag. Okay? Now, ito, yung naka-highlight na ito, yan yung tinatawag ng model. Okay? So, ito yung mag-generate. Ito basically mag-generate nung linear regression na line. So, yung para sa Python at ito naman yung para sa tawag dito ito yung para sa MATLAB, ito yung para sa Python. So, tandaan nyo tong code na ito. So, yan lang yun, one line of code. Net is equal to train network, and then yung input parameters, ito yung gusto nyong matutunan ng machine, and then may parameter na layer and then parameter na options. Dito naman sa Python, it's model.fit, ito yung input parameters, and then may mga epochs tsaka verbose dito. Okay? So explain ko yan later. So kung hindi niyo naintindihan yan ngayon, okay lang, walang problema. Okay, so ang gawin natin is punta tayo sa MATLAB. Okay, at tignan natin yung tawag dito, yung nangyayari. So ito ngayon yung nakita yung code kanina. Okay, so x equals lin space, y is equal to add random fluctuations. At pag niran natin yan, okay, ang lalabas is this plot. Okay, so makikita nyo na random, di ba? Nag-generate siya ng random na data set. Okay. So yan yung gusto nating i-feed sa computer na gusto niyang para malaman natin kung ano yung best fit line dito. Okay. Using MATLAB's code, gagamitin natin yung polyfit na function. Okay, at mag-generate siya ng dalawang numbers since linear lang ito. Okay, yung isang number dito ay yung y-intercept. So ito yung y-intercept at ito naman yung slope. Okay, then ipapasok natin ngayon yun sa random fluctuations para makita lang natin yung best fit line. So ito na ngayon yung na-generate ng polyfit na best fit line. Okay, then okay, now ngayon implement na natin yung sa machine learning model. So sa machine learning model, pag ni-run natin yan, generate siya ng ganyang kadaming data. And makikita natin na meron din siyang ganitong, ipapakita niya rin sa inyo yung progress ng learning. Okay, so hintay lang tayo sandali. Okay. Okay. Yan. So nagtitrain siya at ito na yung training niya. Okay, so meron ditong root mean square error. Okay, makita natin na yung error malaki sa simula and then lumiit, then lumaki, lumiit, and so on and so forth hanggang sa maging approximately 0.3 na lang yung RMSE. Okay, and then dito naman is yung loss function na tinatawag. I-explain ko din ito later. Okay, kung ano ibig sabihin ng loss function. Okay, so dito makikita niyo yung training progress in terms of the number of iterations. So after mga 60 iterations, medyo natutunan na ng machine kung ano yung or na na optimize na ng machine, na minimize niya na yung errors after mga 60 iterations. Okay, makikita niyo rin naman yan dito. Okay, sa MATLAB. Okay, and then ngayon ang gagawin natin is try natin na base dun sa model. Remember na yung model is this, itong net. Base dyan sa model na yan, gagamitin natin yung net ngayon to predict kung ano yung outcome. Okay, so siyempre ipapasok natin yung x, tignan natin kung ano yung magiging y. Okay, so base dun sa learning ng computer, ito yung y na ito yung linear regression na model. Now, isipin nyo, anong naging difference, okay? Kumpara sa human learning or kumpara dun sa code nung MATLAB, which is polyfit. Okay? Ano bang naging difference? Okay, so dito hindi alam ng machine, okay, kung ano yung yung slope at saka yung y-intercept. In fact, hindi niya generate yung slope at saka y-intercept. Ang binibigay niya lang sa inyo yung linya. Okay? So yun yung isang difference. Okay, kumpara doon sa polyfit na model, binibigay niya sa inyo yung slope at saka yung y-intercept. Okay? Now, yung difference between yung model, okay, model is y-test, 6.4420, ito. And then yung actual, based sa polyfit, 6.4490, ang error is just 0.1%. Okay? So, medyo maganda yung pag-predict ng machine pagdating dito sa linear regression. Of course, we expect that kasi sobrang simple lang naman nung model na ito. Okay, nung kailangan gawin nung machine. Okay, now let's take a deeper look into what is actually happening here. Okay, so tignan natin itong gradient descent ngayon. Okay, so dito sa gradient descent, okay, tignan natin kung anong ginagawa ng gradient descent. So dito, okay, na alam niyo naman kung anong gradient descent, ginawa niyo na itong MP before. Okay, so basically, meron kayo initial guess at base dun sa initial guess na yon, okay, hahanapin ng model yung optimum value. Now, depende rin sa initial guess yung pupuntahan niyang optimum value. It could be na ang initial guess niyo is A at ang pupuntahan niya ay B. So ito ngayon yung tawag dito, yung optimum value niya. It could be na pinili niyong initial value ay C, pero nagpunta siya sa D. So nagde-depend kung ano yung pipiliin niyang optimum value or minimum value, kung local minima or hindi. Nagde-depend yun sa initial values na pipiliin niyo. At yun yung dapat na natutunan niyo sa MPs. Okay? Now, okay. May mga notes ako dito. Kasi sa previous na. Sa ibang class ko to ginamit. Now, paano to ginagawa nung machine? Okay. So, let's see. Tanggalin ko na lang lahat ng notes. So, ang ginagawa ng machine is this. Ito yung expected natin na line. Okay? At ito yung data points, yung kulay blue. Okay, so ito yung data actually. So itong X data at Y data, yan yung kulay blue. Okay, so ang gagawin ng machine is, by the way, nilabel natin yung X data at Y data as X1, X2, X3 hanggang X to the N, ganun din yung Y data. So, ang gagawin natin is model muna natin siya as y is equal to b plus mx. Okay? Yan yung, ang tawag natin ngayon dyan is our hypothesis. Okay? Kasi we are hypothesized na we can fit itong data points as a linear function. Okay? Ngayon, i-rewrite lang natin to in terms of in terms of this. Okay? Yung y is now rewritten as h sub theta of x is equal to theta naught plus theta 1x. Okay? May reason kung bakit natin yan i-rewrite. At yung reason na yun ay lilitaw pagdating sa multivariate linear regression. Okay, ngayon univariate lang tayo, single valued linear regression lang. Okay, so basically ang sinasabi ko lang dito is we're just rewriting y is equal to b plus mx to h sub theta of x is equal to theta naught plus theta 1 of x. Na kung saan yung theta naught ay yung y-intercept at theta 1 ay yung slope. Now, for each of these data points, alamin natin yung error. So yung error, halimbawa dito, yan yung E1. Yung error dito, difference between yung true value at saka yung hypothesis is E2. Error dito sa true value na ito at saka itong hypothesis na red line is E3. Ito yung E4, ito yung green yung E5, yung green yung E6, and so on and so forth. So each of these data points ay merong error. E1, E2, E3 hanggang E sub n. Okay, tatawagin natin yan ngayong error na yan as E sub I of x is equal to h theta of x, di ba? Yan yung hypothesis, minus yung true value, y sub I. Okay, yung true value yung blue, yung hypothesis h theta of x ay yung red line. Okay. Ngayon, isa-sum natin yung mga hypothesis na yan. So, add natin lahat yan, or sorry, i-square muna natin bawat isa sa mga yan. Okay. Pagkatapos natin silang i-square, saka natin sila i-add lahat. Ito yung ibig sabihin ng e sub I squared of x, square muna bawat isa, and then i-add natin lahat, sum. And then, just to normalize, we just multiply it by 1 over 2n, where n, okay, n is the number of data points. Now, ang tawag natin dito is the cost function. So, bakit ito, sa machine learning language, ang tawag dito is cost function. Bakit cost function? Kasi, anong tawag dito? If malaki yung error, malaki yung babayaran ng machine. Okay? Para i-correct yung error niya. Okay? Pero kung lumiliit na yung error, konti na lang yung babayaran niya or konti na lang yung suspend yung energy para makorek yung error. So kaya siya tinawag na cost function. So these are costly mistakes. Pwede niyo isipin na ganun. Okay, now ang gagawin natin is yung cost function ay i-rewrite natin in terms of the error. Okay? So this is just the same as this except na pinakita natin na yung cost function is a function of now the theta naught and theta 1. So equal yan sa 1 over 2n, 1 over 2n ito. Sum, yan. And then yung e sub I of x is this. Diba? So h theta x sub I minus y sub I. So ito yung h theta of xi, ito yun. Theta naught plus theta 1 xi minus yi. So ito yun. And then isa-square natin bawat isa dyan, then isa-sum natin. So ito ngayon yung full expression of the cost function in terms of the slope and the y-intercept. Okay. Oops. Okay, so tanggalin ko ulit ito. Okay, so ito yung cost function. Now, this is how you write it in code. Okay, 1 over 2 times n times sum, okay, ng theta naught plus theta 1 times x minus y. Okay, and then square natin yung data na ito. Okay. So, ang ginagawa dito is meron tayong guess for theta naught at saka theta 1. Okay. So, this is how you write it for MATLAB, and this is how you write it for Python. Okay, theta naught tsaka theta 1 ay mga guesses natin. Okay, so dito ang guess natin is, initial guess natin is theta naught is equal to 0.5. And then theta 1 is equal to 0. Okay, makikita natin, ang makikita nyo rito, pag ang initial guess natin is theta naught equals 0.5 at yung theta 1 is equal to 0, ito yung hypothesis. So makita natin na laki ng error. Okay? So malaki yung cost function. Ito yung value ng cost function ngayon. Now, when I run this, makikita nyo na yung red line ay mag-move back and forth. At the same time, yung cost function ay liliit. Okay? So, ganun. Hindi. So, nag-move lang pala yung red line papunta doon. Okay? So, mapapansin nyo rin na ang pinilitan ko lang dito yung theta 1. Okay? So, i-run ko ulit, ano? Okay. So, yung theta 1 nag-run from 0. From anong value? Okay. From 0 hanggang sa 4. Okay, in steps of 0.1. Okay, at some value of theta 1, okay, yun yung minimum yung error niya. Minimum yung cost function. So ito. Okay, so minimum ngayon yung cost function niya for the value na theta 1 is equal to 2. Okay, and then pag lumagpas na ulit yung theta 1 to 2, lalaki na ulit yung cost function niya. Okay. So, pag tinignan natin ngayon to sa 3D, ganito yung magiging itsura niya. Okay. So, bakit 3D? Kasi yung x-axis is theta naught, yung y-axis is theta 1, at yung y-axis is cost function. And makikita nyo na nag-move lang yung data all along a single value of theta naught, which is 0.5. At nagbabago yung theta 1. Okay. So, dito naman, dito, ang pinapakita naman dito, yung derivative ng cost function. Now, since yung cost function is a function of theta naught at saka theta 1, okay, kukunin natin yung derivative as a function of theta naught at saka with respect to theta naught at saka theta 1. So, yung derivative ng cost function with respect to theta naught is 1 over n, okay, times the sum from I equals to 1 ng n of this function. Okay, madali lang yan makukuha kasi, di ba, ang derivative is just 2, pasok, ilabas nyo sa summation sign, di ba, so mawawala yung 2 dyan. Tapos kukunin yung derivative with respect to theta. Ang coefficient ng theta is just 1, di ba? So, ang gagawin nyo dito is multiply nyo lang to by 1. Okay, so ito na yung derivative ng ng cost function with respect to theta naught. Ang derivative naman ng cost function with respect to theta 1, ganun din. So yung 2, ibababa nyo doon. So mawawala yung 2. Tapos yung coefficient ng theta sub 1 is x sub I. So kaya mayroong x sub I dyan. Okay. So yan yung dalawang derivatives. And saan natin gagamitin itong derivatives na to? Sa gradient descent. So if you recall sa MP4, ito yung ang gradient descent is given by this equation. Theta naught is equal to theta naught minus alpha, partial derivative ng j with respect to theta naught, yan yung unang function. And then theta 1 is equal to theta 1 minus alpha, partial derivative ng cost function with respect to theta. Now, i-describe ko yung role ng alpha mamaya-mayang konti. Okay, so this is how you implement it in MATLAB sa left side at saka Python. So ito yung cost function at ito yung gradient descent as a function of theta naught and as a function of theta 1. Tapos ito naman yung bagong values nung theta naught at saka theta 1. Okay, ito yung A na alpha na nandito. Similarly, ganito siya implement in tawag dito in Python. Okay. Okay, now, so ngayon, gagawin natin is, implement na natin yung theta naught dito. At the same time, yung gradient descent dito. At the same time, gagamit din tayo ng value ng alpha. In this case, 0.2. At tignan natin kung ano mangyayari. So, ipapakita rin yung epoch means number of iterations. Okay, so sa machine learning, imbis na iterations ang ginagamit ay, imbis na iterations ang ginagamit na term, ang ginagamit na term ay epoch. Okay, so medyo mabilis, ano? So, bagalan natin ng konti. So, ito yung first epoch, second epoch. Okay, so pwede nyo tignan yung red line at saka itong dot. Okay. Third epoch. Okay, so makikita nyo na yung red line ay umakyat siya back and forth. At the same time, itong dot ay nag-move din siya ng zigzag dito. Fourth epoch. Fifth, sixth. Okay. So makikita nyo na for each epoch, paliit ng paliit yung error. Yung difference between the red line and the blue line. At the same time, yung cost function, nagko-converge siya to a specific value. Okay, so yung cost function ay nagko-converge. Okay, so actually dito, sobrang liit na nung error after siguro, ano ba? After 20 iterations, 25 iterations. Okay, so maliit na yung error. Okay, 25 epochs. So maliit na yung error dyan. Okay, so yan yung nangyayari. And nakita nyo nagko-converge into specific values yung theta 1 at saka theta naught. Okay, yung value ng theta naught is 2.052 at saka yung theta naught is 0.33063. Now, if you recall, ang theta naught dito is yung y-intercept at yung theta naught, theta 1 is yung slope. Okay, so in fact, nalalaman din natin yung slope at y-intercept nung linear tawag dito, nung best fit line na ito. Okay. Okay. So, yan ay para sa alpha na 0.2. Okay. So, now, ano ba yung alpha na yan? Ang tawag natin dyan sa alpha na yan is learning rate. Now, this parameter is very important. Okay, kasi tulad ng ng initial conditions, okay, magde-depend din sa learning rate yung tawag dito, kung gaano kabilis matuto yung machine. I mean, that's why it's called the learning rate. If you choose the correct learning rate, mabilis siyang matututo. Okay? If you choose the incorrect learning rate, okay, ang tawag dito, posibleng hindi siya mag-approach sa isang value or posibleng hindi siya, tawag dito, malagpasan niya talaga yung optimum value. Now, sa MP, itong learning rate na to ay yung H. Diba? So, naalala nyo, sa step 8, pina-optimize ko sa inyo yung H. Kaya siya kailangang i-optimize kasi importante yung learning rate. And if you done the MP correctly, yung makikita nyo kung paano na-optimize, kung paano natututo yung machine based on the learning rate that you choose. Okay. So, dito, tignan nyo. Binaba natin yung learning rate. Tignan natin kung anong mangyayari dito. So, kanina 0.2, ngayon 0.1. Okay, so, kita nyo na by choosing the learning rate correctly, konti na lang yung steps niya bago siya mag-converge dun sa actual na value, sa minimum error, sa minimum cost function. Okay, so, dito, epoch 2, epoch 3, epoch 4, epoch 5. Actually, sa epoch 6, medyo okay na siya. And ang ginagawa niya na lang is, sinistraighten niya na lang yung line. Okay? Kumpara sa kanina, nung 0.2 yung ginamit niya na learning rate, medyo sumasayaw yung red line, di ba? At yung cost function nyo din ay nagsiswing back and forth dito. Dito naman sa sa learning rate na ito, okay, makikita nyo na, okay, nag-start siya from here, pero diretso na siya, medyo nag-slope, bumababa na siya papunta dun sa optimum na value niya. Okay, so optimum value ng cost function. Okay. So, another value for the learning rate, 0.5. Tignan natin kung ano mangyayari. Anong napansin niyo? Mas mabilis siya, di ba? Pagdating dito, pabasa ka agad doon and then tawag dito, pumunta siya dito sa point na ito. But, tignan niyo yung red line. Hindi siya fit dun sa blue dots. In fact, tabingi siya, di ba? So, it means na if we choose this learning rate, kailangan pa nating i-extend yung or padamihin yung number of epochs para mag-approach siya sa optimum value niya. Okay, so in this particular example, yung learning rate na maganda is 0.1. Okay, kasi yung 0.1 already gives us a very small error in a minimum number of epochs. Okay, so yan yung for this learning rate. Okay, ito learning rate na to ay 0.1. Okay, tignan natin kung ano mangyayari. Okay, so even worse kaysa 0.05, right? Okay. Yeah. So ang layo ng ano, ang laki ng error dito banda at saka doon banda. Okay, 0.5. Pag 0.5 naman, hindi siya nag-converge. Okay. Kita nyo, ang laki-laki ng values ng cost function at yung red line ay sobrang layo dun sa blue dots. Okay. So, dito makikita nyo yung importance ng pagpili ng tamang tawag dito, tamang learning rate. So, to summarize, a small learning rate converges to minimum slowly. Large learning rate converges to minimum faster. But if it's too large, baka hindi siya mag-converge. Okay, so nakita natin na yung 0.1 yung best na choice. Okay, paano natin implement itong gradient descent na yan? Okay. So, basically, tulad nung ginawa nyo dun sa MP, i-iterate nyo lang ito until mag-converge siya to a specific value. Sa MP, meron kayong function, okay, na kung saan tinitignan nyo kung paano nagja-jump yung point, di ba? Papunta dun sa minimum value niya. Dito, yung function ay yung cost function. You're trying to minimize the cost function. So you want the cost function to be as small as possible. And you do that using the method of gradient descent. Okay, now, fortunately, pagdating sa machine learning, hindi nyo na kailangan nung code na yon. Kasi meron ditong, ito lang ita-type nyo actually, gradient descent. In this case, stochastic gradient descent with momentum. Okay, so yun yung ibig sabihin ng M. So, again, ito yung model. Ang model is called net. Para ma-train yung model, you use train network as a command. Ito yung input value. So, ito yung gusto nyong data na i-train. Then, meron kayong parameter dito na options. So, sa options, nandun yung tawag dito, model, nandun yung technique na gagamitin nyo to minimize. Now, marami pang ibang techniques sa pag-minimize. Pero ang tawag dito, for basic operations, for basic tawag dito, learning, okay na ang gradient descent. So next meeting, i-describe ko kung ano yung mga tawag dito models na available or techniques na available. Kanina, nag-describe tayo nung number of epochs, di ba? From 0 to 50. You can also do that here sa MATLAB. Just type in max epoch as a parameter and then i-type nyo kung ilang epochs. Dinescribe din natin kanina yung learning rate. So ito, dito nilagay natin yung initial na learning rate to be 0.0001. Okay? And then, basically, ito ang ginagawa lang ng plots na parameter is to plot out yung training progress. So, yun yung nakita nyo kanina na graph nung RMSE at saka nung ano na nga yun? Anyway, nung RMSE. Okay. So, yun yung options na nandito. Okay, next meeting, i-describe ko kung ano yung mga layers na ito. So, sa Python, ganun din. Sa Python, merong stochastic gradient descent. So, yan yung optimizer niya. So, ito yung ginagamit niya to train the model, to minimize yung error. Yung loss function na ginagamit is mean squared error. Okay. So, sa Python, ito yung model ninyo, and you fit the model gamit yung input, number of epochs, type in nyo rin yung number of epochs, pareho dito, 100, 100. And then yung verbose just means na pag zero, hindi nyo i-display yung training progress. Pag 1, i-display nyo yung training progress. Sa MATLAB, tanggalin nyo lang itong parameter na ito kung ayaw nyo i-display yung training progress. Pero sa Python, 0 to pag ayaw nyo i-display, 1 pag gusto nyo i-display. And then, syempre, ito na yung pag-plot nung model, okay, in terms of the loss, and then, syempre, yung labeling lang naman. Okay. And then, itong dalawa na to ay yung mga layers. Again, later ko na i-describe yan. So, next na. Oops, okay. So, meron pala akong ganito. So, ito yung model na loss after implementing it in Python. And then, wait, anong ginawa ko dito? Okay, so pinakita ko lang yung, ito naman yung model training progress pagdating sa MATLAB. Okay, so ang dinidisplay dito is yung loss. So essentially, ito yung loss function niyo. Okay, itong loss na ito. Okay. Okay, now, okay, so tulad sinabi ko, next meeting ko na i-describe yung ano na yan, yung function na yan. Okay, so anong natutunan natin for this meeting? So for this meeting, okay, ang natutunan natin ay kung paano implement or kung paano nag-work yung machine learning, at nakita natin na yung basic na code to implement yung machine learning. Okay? So sa MATLAB yung train network, and then sa Python you use the fit command para mag-train ng model. Okay, o mag-train or para mag-develop ng training model. Okay. Now, sa next meeting, ang pag-uusapan naman natin ay neurons. Okay. Na-describe ko kanina earlier dun sa slides na meron ginagamit na neurons para mag-develop ng or para i-train yung machine. Dito sa ano na to, sa ginawa natin kanina, iisa lang yung neuron. Yun actually yung layers. Okay, so yung number of layers describe the number of neurons. So kanina, hindi naman natin kailangan ng maraming neurons just to train the model. Okay, but eventually, or depende sa complexity nung gusto nating i-train sa computer, yung number of neurons na kakailanganin natin. At yun yung di-describe natin sa next na meeting. Okay, so kung wala na kayong tanong, or baka meron kayong tanong regarding this lecture. Yes, okay. So ang tanong is, paano malalaman yung appropriate na learning rate na gagamitin? Okay, so pakita ko ulit yung slide. Wait. Okay, so dito sa slide na ito, makikita nyo dito na merong initial na learning rate. And Dito, ang nilagay na learning rate is 0.0001. Okay? Now, there's an option sa MATLAB para baguhin yung learning rate for each epochs, for each epoch. Okay? So, aaralin natin yon later. So, to answer your question, hindi mo na kailangan actually isipin yon kung ano yung tamang learning rate. Ang kailangan mo nalang tignan is yung training progress. Okay, dapat hindi ito yung pinakita ko. Ito dapat yung pinakita. Okay. Ang kailangan nyo lang tignan is yung training progress. Okay. So when you choose a learning rate, tignan mo kung yung learning progress nyo ay may ganitong shape. Pa ganyan, pababa. Okay. Training progress. Okay. Titignan nyo rito sa yung training progress sa Python ay pa ganyan. Yan ang gusto nyong ma-achieve. Okay, na training progress. So, if you choose a learning rate na mali, na initial learning rate na mali, pwedeng mangyari sa training progress nyo ay flat, pwede siyang umakyat. Okay? So essentially, actually, parang hula-hula lang din siya. Okay? But sometimes, oftentimes, nag-work naman yung default value nung codes. Like, for example, dito sa Python, pansin nyo, walang training dito, di ba? Walang learning rate. Kasi ang default na learning rate, I think, dito is 0.01. Okay, so, and nag-work naman kasi very simple lang naman tong na to eh. Tong tinuturo natin sa computer, di ba? So, sometimes nag-work 'yan. But if you find na medyo kailangan yung i-tweak yung yung learning rate, meron ding command na i-add lang dito sa fit or actually dito sa compile. Okay, sa options. Okay. Sa options dito sa MATLAB naman. Okay, so yun yung sagot dun sa tanong na. Okay. Okay, first question, Simulinks for MP5. Next question, Simulink for MP5, close na yung submission bin. Close na yung submission bin. Kasi ano bang sinabi kong deadline sana? Dali, check ko lang. Yeah, 21 November yung Kasi added yun sa MP4. Yung sorry, ano pa tanong mo? MP5 ba? Simulink? Hindi. Yung Simulink is, yung Simulink for MP5 siya, for ODE. Kailan ba kayo magsasubmit ng MP5? Bukas, di ba? December 6. At, maaga ko siyang kinlose. Okay, let's open this again. Okay, so 5 December 23, 59. Okay, so naka-open siya ulit. Hanggang today lang. No, wala tayong F2F. Wala tayong F2F sa lab. Kasi hindi pinapayagan ng math yung ng DMCS yung walang teacher na magbabantay. So yung isang question is kung may F2F for the lab tomorrow. So wala tayong F2F. Okay, any other questions related to this topic or sa course? Wala na? Okay. So, again, next 3 meetings, ano tayo? Face-to-face tayo. Not face-to-face. Online. Okay. Okay, so kung wala nang tanong, then remember you can always ask questions via email or kung medyo komplikado yung tanong ninyo at hindi kaya explain via email, pwede naman tayong mag-Zoom consultation din. We'll just set up a schedule. Okay, kung gusto nyo mag-usap via Zoom. Okay? Okay, so see you all on Thursday. Thank you.